A QA engineer with more than a dozen years of experience, specialist in open source and security issues. If those tools and applications are close to your heart, then listen closely to what Alex Todorov has prepared for you. A big round of applause, please.
Okay, thank you. Please come closer. It's not so scary topic. Disclaimer, I am not a security expert, I am a tester. So please come closer. I'm going to show you examples, mostly from open source projects that I work on and mostly from one specific project, how we approach security into that application, what we've dealt with, what kind of tools, a lot of tools. I'm going to show you examples of issues that we have found in our own application. So let's get started with this picture. This is supposedly to some authors how we should be doing testing and development nowadays. We have all the development and release with blue, and you have the testing activities with green. This picture doesn't say anything about security, and I say we can do a little bit of testing in the context of security everywhere along the way. I don't have examples for everything, just for a few of the areas. You are also familiar with this picture. There was even a presentation this morning. Shift left, shift right. Again, this doesn't say anything about security. And again, I say we testers are in a good position to contribute to improving overall security in the product without being experts. So how do we do this? I'm going to show examples from the application under test to realize, just to understand how we started thinking about the concept of security in our application, what kind of tools do we have, then moving on to the software dependency stack with a lot of examples why this is important and what we did there, testing infrastructure, and then at the end, if time allows, hopefully, just a few ideas what we can do even more. So all of these things can be done by testers. At one point in time, we've got this bug in our application. We expose user credentials in the database. Looks kind of scary. And you have to realize this is a legacy application which the current team did not create in the first place. So we adopted the application. It is an open source test case management system, more than 10 years old, was written very horribly in the beginning. And for a long, long time, nobody was thinking about security in this application. Nobody was thinking how to make it a good application. Just they cared, okay, let's build something and push it to GitHub, and that's it. The way this bug happened is we have an API layer in which we are logging all of the API calls, maybe for debugging purposes, maybe for auditing purposes. This is not malicious intention, it's a very good intention. We log the method name, the HTTP request, and all of the method parameters. And lo and behold, you have two special methods, authentication login and user.update, where the first parameter is the username, the second one is the password in clear text. This goes straight into the database. So this thing happens and we realize, oh shit, we are doing a crappy job around security in this project. Let's start thinking about this. So how do we analyze the software under test? And the good news here for us is that we testers analyze software under test as our daily jobs. This is what we do. And we just need to be given some properties which we can start thinking and designing our testing around. And every modern application has all of these properties today. So you have actors in the application, different users, maybe groups, teams, organizations. On top of that, you can have multi-tenant architecture, which is basically separating different sets of users. So you can start designing testing around that. You have different places where you interact with your application, API endpoints, backend functions which serve HTML back to the browser. You have a user interface for the people, and this is coded around some kind of templating language. You have permissions, you have database, you have logs. So different places where you can interact with the application. You have actions that the user can perform, and these are pretty standard, like create, delete, modify objects. And I want you to pay attention to the last one, modify related records or related properties. So if you have two database tables which have a many-to-many relationship between them, pretty much all modern web frameworks, they will create a third table in the database to store the relationship. And they will automatically create permissions around these tables. So it is possible that a user does not have permission to modify any of the two objects, but they are able to modify the relationship itself. So that is possible. We have seen such a problem in our application. And at the end, at the bottom, you have the distribution layer, which I'm not going to talk about. But this is how do you distribute your software to your customers. Can be native Linux packages, can be Windows setup .exe files, can be an application store, can be a cloud platform. Again, good news is all of these vendors, they have extensive documentation how you should be building your product to be released on these platforms. They have a lot of security guidelines which can be followed, and some of these documents are very big, so that's quite a lot of work that you can do to make sure stuff is secure. A few examples. We started thinking around this framework, okay, what is happening in our application? Is this the right thing that is happening, or is it the wrong thing that is happening? And we have this problem. Bogus permissions in one of our API functions. Everything here that you see is correct, except the few lines in red. So we have two functions, create and add tag. They are safeguarded with permissions. The actual permissions are correct. There's no error. There's no typo into them. The problem is that the create function exhibits two different functionalities, so two different behaviors, depending on the input values. And in my opinion, these are two separate functionalities. They need to be controlled separately, not be merged together. This thing can happen, copy-paste these 3 lines very easily. In reality, in the actual source code, there were like 10 lines above each other. These 3 lines copy-pasted from the function below, just because convenience. So that's a problem. Another problem that we've discovered in a lot of our HTML templates, so not only one, but in many HTML templates, is we do try to check for permissions, and we say, okay, if the user does not have permissions, let's hide this menu option, or let's hide this button so they cannot click it, and hopefully on the back end, the function that receives the action is also safeguarded with the same permissions. There are typos, there are copy-paste errors, and nobody paid attention for that. And what we realized, the important thing we realized is when many of the existing test cases have been designed, especially with automation, is we test the positive scenario with the user in the database and assign all the available permissions to him, load to the page, verify the button is present, which it is, pass. Then we design a negative scenario where we create a user in the database and we remove all the permissions from that user, load the same page, verify the button is missing, again, pass. What we learned is when we do tests, especially automation around permissions, we need to be very granular. So only in that way we are going to find that something is not okay. Moving on to a lot more errors. And this is the point where we realize, okay, these things, they form a pattern, they are repeating. So let's start investing in tooling. I did have an Ignite talk about customized static analysis plugins. This is one of the tools which we invest quite heavily. We have more than 20 of them, and we have several designed around permissions, so they will check if every function requires this permission required decorator, if the permission label is correct. We are working to extend this to be able to discover also automated tests around these functions to give us information. Do I have proper testing coverage around everything that has to deal with permission in this application or no? So this is an ongoing effort. So that's the first thing that we did. And this is again something that you can do, start investing in thinking about testing around security, start investing in customized tooling to discover more information about the software under test. Then we realized, okay, let's get a step back. There are actually tools designed to do this for us. Let's search for them and start to apply them in the project, see how it goes. The first one we discovered and we like is called Bandit. We work with Python, so most of my examples are for Python. I do have some for other languages later. Bandit comes from the OpenStack project, so it must be good. You know, everybody has heard about OpenStack. What it does is search for specific functions, specific modules, specific coding patterns which are known to have vulnerabilities, or they are known to lead to problems in different contexts. That may not be a problem in your particular application. But we decide, okay, let's follow the tool, let's make the tool happy, see what we can see. Most critical issue that we have, remote code execution, caused by exactly these two lines in the source code. What they mean is we are happily receiving anything from the browser and executing this into the namespace of the application. This can be exploited very, very easily. Indeed, we do have a public demo website, and somebody deleted everything from the database at some point in time. We don't know if they used this exact vulnerability or they did it in some other way, but the fact is they deleted everything. So moving on to other types of issues that Bandit discovers is hard-coded passwords. This is designed as a safeguard measure. If you, by accident, you're doing some testing, you're doing some debugging, and commit your passwords to GitHub, and you push them. This has happened. We pushed our cloud credentials to GitHub. These tools are designed to prevent this, or at least tell you, okay, you made a mistake. Now you have to go back and update all of your passwords and API keys. A warning here that a lot of the errors may come from your test suite, and you either need to deal with them one by one or redesign your test suite in some way to not have so many errors, and this may take a lot of time. But you need to be diligent and explore every single report one by one to figure out if it is a problem or if it is not a problem. Another interesting concept from this static analysis tooling around security is not ignoring the exceptions. So they will detect patterns like try except pass or try except continue. Initially, this doesn't sound like something that has to do with security. However, the tool's documentation tells you, listen, if you ignore exceptions, then you have no idea what is happening in the application. It can be malicious or it can be a genuine error. If it is a genuine error, then please fix it. Don't let it just be like that. So another example, we remove these try except blocks in our application everywhere. We remove them everywhere. And shortly after we get this exception, that is reported in Sentry, which is our monitoring service for crashes on production. And if we look more closely at that, we see it's a value error. We try to convert something which is called TC1 for test case number 1. We try to convert the string into an integer. If we read the source code a little bit more carefully, we'll see there is an HTML form which is validated. It's reported as valid, so data validation passes. And then we take all of these values and send them directly to the database. So that is SQL injection waiting to happen. In this particular example, we don't know if the user was just careless and they didn't type something correctly, or they were actually very clever and trying to disguise their probing for SQL injection in this very smart way that would look like an innocent error. And the good news for us is that we don't really care which one is the case. That is a crash which happens on production. We treat it with higher priority than other stuff. We validate the input data properly, so we expect an integer number, and the user will get an error in the browser, so this thing, after the fix, never gets to touch the database. And this is fine. This is what not ignoring the exceptions gives us in the context of security. We just get more information that something is happening, and we can act on that. Another common set of things that tooling around security checks is using hash functions, random function, and they tell you, listen, we know that these things are kind of out of date. We don't recommend you use them, and because the tool doesn't know how you use this function, it thinks the worst case. Oh my God, you are using random for dealing with passwords, with dealing with cryptography. And you may be thinking, nobody in their right mind will use the random function for passwords and cryptography. However, this is exactly what this application was doing. So that function, called set random key for user, is called when the user registers an account on the website. We try to generate some random string, send it back via email. The user will click on the link and validate their email address. This is what this function is doing. So we change from MD5 to SHA1, then we change to SHA256, and then Bandit complies in exactly the same line. And oh my God, you are using random, and on top of that, we are using it in a very stupid way. What to do is, lesson learned here is every programming language has modules and functions designed to work around secure passwords, salted tokens, and so on. So just learn about them and start using them. This is the lesson for the development team. This is what we discover. And last lesson is when you have input files, import, export functionality. Export is probably fine, But when you have import, you have to be very, very careful. The actual error in our case comes from the XML module, because this is super insecure in Python. It's known by the whole world. But that can be also CSV, can be JSON. Just search for JSON CVEs for Ruby on Rails, and you will laugh a lot of times. Any kind of file format. We also supported the import of OpenOffice documents. This opens up for SQL injection. This opens up for code injection. If you're doing this by yourself, that is a big, big red flag for you as a tester. Something is going wrong. If you are using a library, supposedly open source, it must be the latest version. You must make sure that it's well tested, it's well supported, this library, and not something that somebody wrote 10 years ago and abandoned on the internet. And these things happen all the time. Moving on to the next tool. So we discovered this beautiful lands of tools which are available to us for free. So we just started implementing all of them that we see and try to go with them for a while and see what happens. This is called Coverity Scan. It is well known in the industry. It is one of the few non-open source tools that we use. It's commercial, but it's free of charge for open source projects. And I want you, so it's very similar to the other tools. I want you to pay attention to this graph at the top, like orange, reddish line. It goes pretty constant. That's the number of issues that we had. And at some point, it starts skyrocketing. And the question is, what did we do? What did we fuck up as a team so that this line skyrockets and the tool reports lots of errors? And the answer is nothing. We just realized what we were doing when we developed the software. And that's pretty much what everybody is doing. You have a problem, first thing you do, search on the internet, do I have an open source library that solves this particular class of problems? You find several, play with them a little bit, usually pick the one you like the most or the one in which you can understand the README and you understand how to integrate. Write a little bit of glue code to add this into your current project. Git commit, git push, and this thing goes into production. If you are a startup, if you are a small company, you know that taking something from the internet and deploying to production can take very little time, can be just a couple of hours in some cases. If you are a large enterprise, maybe this process is much more restrictive. Maybe there is some formal review process of what kind of libraries and what kind of stuff you're allowed to use. So that's a little bit better. But you need to be careful when you do this, because bugs happen. Sometimes, bugs are errors which are unintentional by the developer who created the library. In this case, you have library that deals with attachments. They have this very innocent bug. When you delete the attachments, they forget to delete the content from the file system. And you can upload many, many files over the course of a day or so and fill up the disk space of the application. It will start crashing, or it will increase the bill for cloud storage. So one of the things will happen. Another thing is you have packages which are outright malicious, like this one, SSH Decorator. Was popular in the Python world, and this thing get published on Reddit last year in April. The package was taken down from the internet immediately. I don't know the history of that particular package, but what the screenshot shows is this package is stealing your SSH keys, and not only that it steals them, it sends them over non-encrypted HTTP connection to some PHP backend, so that everybody who is listening on the line, including your ISP provider, they will also get access to your SSH keys and hence access to all of your systems. Very, very bad thing. Python people went crazy over this. Another example, in this case, we do know what happened. A very popular Node.js package called Event Stream. Example is from last year, late November, early December. Just read the bullet points. So this guy, Dominic Tarr, he is the original author of this package. He released this on the internet. It became very, very popular. Then he moved on to some other stuff. He was busy, didn't maintain for several years. At some point in time, he receives an email from somebody unknown to him, and the email says, I want to help you. Please give me access to GitHub repository. Please give me access to Node.js package repository. And he gave full access to that guy. The error on the part of the author was the account on GitHub that requested access was without prior history, no picture of a person, no real name assigned behind the account, and on top of that, the account was from China. So very suspicious account. However, he gave full access without asking any questions. What this malicious individual did was, in the course of about 2 days, he added, instead of fixing bugs, He added a new payload to the package along the lines of mining cryptocurrency, released new version. Everybody saw, oh, new version. There's not been a new version in the last 2 years. Let's upgrade immediately. Wow, 2 million downloads in just a couple of days. If you read Node.js blogs, npm.js package repository, they actually have dedicated team right now to monitor for these types of malicious packages, because this activity has become common in the Node.js land. Malicious people trying to push payload which mines cryptocurrencies, and you just install into your web pages. This is apparently very, very popular right now. Another example, so previous one was just a single person, he's tired, he made a mistake. But if you think commercial companies don't do the same mistake, you are wrong. This is InfluxDB, a commercial company. They have their client libraries open source on GitHub for people to use them. So about 5-6 months ago, they get a pull request, which gets merged into the master branch. So code is updated. Somebody review this pull request before merging it. You have comment which says danger in the pull request. You have the words SQL injection, the word vulnerability in the comment. So the person that is doing the code review, the person that is merging, supposedly should get this light bulb. Okay, this is something critical and we need to release a new version immediately. No new version for 6 months. So this is what they did. And to answer the question, what we did is we realized that having software dependencies means trusting other people with our production environment. And how many people you can see from the picture. We have around 30 physical persons that contribute to the source code of our project, and we have more than 20,000 other people contributing to the dependency stack. We have no idea what is the level of experience of these people. We have no idea how this software was tested or not tested. We have no idea if they are malicious or no. So to answer, why the graph rises rapidly is we realized this is happening, so we started running all of our tooling against the entire dependency stack. Not only against the application under test, but against everything that it depends on. And in reality, most of the errors that are reported by the tools come from somebody else's source code, not something that we control directly. But it's a good thing that we have this information, we can act on it, we can work with these people over time to fix it. It's a very, very, very slow process. So moving on to more examples for the dependency stack, this time coming from the JavaScript world. That's another project we work on, React.js application, nice looking. And last year, this tool gets announced. It's been around for a long time, but it got announced as a command integrated with NPM, called NPM audit. On the day it was announced, we decided, okay, that sounds cool. Let's run it against the project. Immediately, bam, 10 different issues. 2 of them high severity, both of them coming from jQuery, 2 different versions of jQuery in the same project. That is completely ridiculous. So obviously, we work to upgrade these versions and to unify them and at least use one, hopefully the latest one, which doesn't have any issues until proven otherwise. Again, this takes time. Similar functionality exists in GitHub. So they support a lot of different languages, not only JavaScript. This is screenshot taken from the same project on the same day when we run npm.js. So npm audit. npm audit says 10 issues to high severity. GitHub says everything is fine, you're cool, no issues. So what do? We need a third tool, Arbiter. So we discovered this thing called Snyk. It's a software as a service, a very cool startup. They support many languages, including JavaScript. What I like about them the most is that they actually have their own dedicated research team. So they try actively searching for problems related to security. So we have noticed Snyk being able to report the same issue 5 to 10 days before GitHub is reporting this issue. So that is a lot of time where you have time for reaction if it's something critical. So lesson here, don't trust your tools, or at least don't trust any single one of them. I told you we use a lot of tools. Our basic policy is if we find a tool which we think is cool, we enable it by default, run with it for a while, and then we figure out how this tool is performing, whether or not it's giving us valuable information whether or not we actually understand the information that is reported back to us. Maybe the case that we are just idiots and we don't understand and we don't know what to do with this information. But the lesson is just enable as many as possible. You have no excuse if you run CI to not enable all the tools that you have at your disposal. You have no excuse. If you're using a different programming language than Python and JavaScript, of course, just Google, start static analysis tools. The first list that I was able to find, this one, awesome static analysis on GitHub, it has 20 different tools with the word security in the title or in the description. So a lot of tools for many, many programming language. If you start searching for dedicated security scanners, security static analysis, vulnerability static analysis, you will discover many, many more. Some of them, of course, very good, some of them very poor. Just a random list of tools I've come across, not use all of them. Moving on to infrastructure. So why this is important? Production infrastructure, we do know that it must be secure. We do have people that deal with this. Testing infrastructure, however, is a different story. Usually, you are a small team or maybe just a single person, and your boss comes to you and say, oh, you're a rock star, you're the most technical, you're the most senior, and I want you for this new project. It will be very cool application, and by the way, you have to set up Jenkins and all the CI environment, and you have to maintain this. And on top of that, you also have to help mentor junior members, and you need to write the test automation framework. Oh, and by the way, you need to actually implement some tests, like automated scripts. All of this is your job, and what you're going to do, you ignore your responsibilities around infrastructure. Of course, that's the most natural thing. You don't get paid for that. This is on top. Option number 1, choose a cloud vendor. In this case, it's Atlassian.net, and you think it's secure. However, not always is the answer. That is an example of one particular company in Sofia. I'm not going to tell you the name. This is their entire product roadmap. Also, you have their entire employee directory, and you have meeting minutes available, publicly available, without username, without password, in their Confluence page. This can be discovered by going to the home page of the wiki. It will ask you for username and password, but then if you start searching, try to discover all of the other pages, or you just start navigating, manipulating the address bar, then you come around these pages. Very, very interesting information. I've told these guys that this is publicly available. They say, no, it's fine, we fixed it. Who cares? Obviously, they don't care. Example number 1, different company, this time German company, again Atlassian.net instance. First time I get access to that, of course, I try my previous trick to figure out if these pages are available. Well, they're not. Good for these guys. We work on a project with this company, so we naturally need access to Jira, and the answer was, listen guys, we kinda couldn't figure out how to limit your access only to the project that you need to be working on. You have access to absolutely everything. Please be careful, don't delete something. And just my example is, we've got access to this acquiring and banking business project. There is very, very interesting information in this project. Talks about payment providers, talks about partners, talks about money. Very interesting stuff. The most ridiculous things, however, is the project is long, long over. I still have access to this Jira instance. I have met with this company 3 times, and I've told them every single time, listen guys, I do have access to that. Please, disable my account. They don't care. And admittedly, from what I've heard, I'm not the only guy that still has access to this Jira instance and to that information. Amazing. And moving on to your CI slaves, the systems which are actually designed to compile and to execute programs. And these can be exploited if you're not careful. This is an example from a project which is available on GitHub. And the interesting thing about this project is the source code itself is public, but the testing infrastructure is private. You cannot access this testing infrastructure directly, but you see that it is there. You see these machines reporting statuses pass and fail on GitHub. So, green and red, green and red. And you can see their host names, but they're behind a firewall. So I sent this pull request. It's a very innocent pull request. I will show it to you in more details. The story here is this is part of a test script which is using this import program, which has been compiled in the local directory. And the developer one day tells me, Alex, you don't need to compile this into the local directory anymore. We have this program installed system-wide on all the slave systems, so please use it from the system-wide location. I send my pull request, of course, and the first time I did so, I forget to update the last line. So effectively, I have the line with red. So I'm doing some cleanup actions, and I remove the import program. My pull request passes. I realize my mistake. I send the pull request again, and it starts failing because the import program is missing. At this point, I realize two things. First, my tests are running with full privileges as root on the system, so I can do everything I want. I have trashed my Jenkins slave, so now somebody needs to fix it. And second, I can exploit this very easily. I can just open an SSH tunnel, traverse back to the slave system. From that, my next target is the Jenkins master, which is probably left unupdated, maybe unsecure. There are a lot of exploits for Jenkins in particular. There are a lot of plugins which people don't maintain, and you just download and install them and don't care about upgrading them. So that's a very easy target. I can do this over a long weekend. I can do this over the night. My team is in the US. They will never know what happens. And you can find projects like that everywhere on the internet. Very easy to find. Just need 30 minutes to search for that. So, lesson here, treat all of your testing infrastructure as production because it can be used against you. Validate all the settings. Maybe you think you have configured it correctly. Don't think validate that. And also, if today something is configured correctly, that doesn't mean that tomorrow, next week, next month, after an upgrade, there will be a bug, or maybe somebody changes something without telling you, behavior will be the same. So validate all of these things, of course. And last, an idea. The person behind the computer doesn't actually care about security. They don't care about what you do at all. They care about doing their job. They care about solving a particular problem with your software product. That's why they buy your product, or that's why they use it. Case number one, your requirements for password security are ridiculously high. What people do all the time is they will write the password on a sticky note, put it on their computer, or they will copy-paste the password and send it over email, send it over Slack, non-encrypted communication, usually with the text to some coworker, I have this problem, can you log in on my computer and help me please? This is what happens. I've done this personally. I think everybody has done this in this room. Another case, maybe the application needs to be secure, but it's actually not by design. This is a payment provider in the US, and their level of security is nowhere near what I feel comfortable with. Good news as testers is that we can actually take part of design sessions with software architects, system designers, even usability people. And we can spot these things. We can tell them, listen, guys, we should fix this. We need to work around that. Justin Meyer says use multi-factor authentication everywhere, but the actual message here is make the application usable, and the person will not care about your technology solutions. So if you make the application easy to use and don't prevent the person or don't block them, don't make it too hard for them to achieve their goals, they will happily adopt any kind of security technology solutions you want. And the last example is I have these guys located somewhere in Canada as far as I know. They put this thing on GitHub. So they didn't care to change their database username, left it by default. Password is empty by default. They changed the database host, which is an Amazon instance, publicly accessible over the internet. They didn't bother to put a firewall. Took me only 30 seconds to connect to this database and to examine what's inside of there. We also send them an email. This is still not fixed. So this is my checklist for today. As tester, just think about security. Think where we can contribute. Think where we can spot problems. And every single contribution along the way counts in making the overall security of our products better and better with every iteration. Thank you very much. We probably have only 2 or 3 minutes for questions, so be quick.
So who's first?
Do you use OWASP dependency check? OWASP dependency.
Okay, so I have heard about OWASP. We have not used it yet. I mean, we have not come to this. From what I know, it's good tools coming from the OWASP project, but I don't have any experience with any of these tools.
Okay, thank you.
This is just yet another thing to add on top of what exists.
Any other questions? Thank you very much. A
Okay,
big round of
thank
applause,
you.
please. Alex.
Yes, and please don't be shy. I have open source stickers. If you want stickers for your laptop, please come grab some. Thank you.
One more announcement. There's a contest. Check it out in the application. Thank you.